Hey everyone. Oh my gosh, I look really dark. Oh well. I hope everyone's had a fantastic Easter weekend. Welcome back to making a Pokemon save editor in C. I think this is part 13, I want to say. It might be 12 or 13. So we are deep within the Pokemon data rabbit hole right now. And I have been struggling the past episode with kind of loading Pokemon data and especially Pokemon data that I think is or is not correct. And what I mean by that is uh, the Pokemon data structure is intentionally made kind of difficult to work with. So we've got things like there's just straight up 48 bytes of quote unquote encrypted data here, and there's like a specific kind of decryption key that you need to make, and then you apply that key to the data to get access to these kind of raw values that we have here. So that's what we've been struggling with. Um, Previously, I off screen read through this text file a little bit more. I believe this is kind of the basis for the Bulbapedia article, which turns more or less kind of rough looking notes into more informative guides. But but a very interesting theme that is here in this text file, all throughout, is references to things being kind of in reverse. I don't know if that is to do with Endianness or we literally just want to actually take these in reverse. So what's interesting here is that actually the checksum value is reversed. Um, and so is the actual data as well. Now that is very interesting indeed. So we probably have a issue. I've been doing some debugging earlier. I basically filmed another part earlier today and I made no progress whatsoever, so it has been cut. But nothing interesting happened. The only, I think, tangible change I made to the code was I actually removed the intermediate word variable from here. So now we just have like source pointer and dest pointer. I'm actually going to call these source and dest pointer. So yeah, we kind of have like a new value here, our decrypted word, which is the dereference source pointer XORed with the key. That's pretty much the only change I ended up making. Everything else was just pure debugging, so kind of printing intermediate values and making sure that they made sense. So the issue we have is yeah, the actual Pokemon data substructure. So we know which order we want to be looking at the data, but we, in our init function, probably want to reverse these. So instead of... Yeah. Um, yeah. I think we probably... So rather than writing these 12 bytes at a time, they have to be written in reverse order. So we should probably do that. I guess for like reverse it and like text as well. Um, we probably just want like a utility file, I guess. So in here, I'll just call this util. Actually, I probably should have made just a C file to go with it, so I'm actually going to remove that. and add a source file with a header. I'm just going to call this util. So the first thing that should probably go over there is the text encode function. Like, I feel like that kind of makes sense to actually move into this file. So let me grab that and just place it over here, not in the header, but over here. And okay, so size t. Where on earth do we get size t from? Is it an int type? We need a separate import for that. Size t? Maybe CPP reference will tell me where it is. stdio.h. Yeah, okay. So we have that, and we also need memset, which is probably going to be in standard lib. It's not in standard lib, it's in string. Yeah, okay. All of this makes sense. So that's our text encode function. This probably needs to be defined in the header. And over here we actually need to include our util file. Want to include it, not include. Then we should no longer have broken references to text encode, which I don't think we do. Fab. So we need a new function now, which was to basically reverse like kind of a byte order. So let's call this like reverse. Let's just call this reverse 32-bit. And it probably needs a... some kind of 32-bit destination, and then some kind of source as well. I guess makes sense. And I suppose that should be const as well. I mean, do we want to reverse it in place? That might be easier. I'll probably put a comment in there for now and say, do we actually want to do that in place? So, what was it? It was a void. Let me just put that down there. Reverse 32-bit. So that is a pointer to the place where we want to write. And this is a pointer to the data that we want to input there. But what we're going to need to do is actually create an unsigned character pointer and actually set this to unsigned character of source. So cast that down. We don't need a queue, but I feel like what we want to do is just take... I actually did this code as an example not too long ago. So we want to take this pointer, move it to the end, and then kind of work its way back. So the size of a uint32 minus 1. And yeah, we just have a for loop where we take the bytes and then decrement p, which I guess we can do. Although actually, I mean, we don't need to do incrementing, right? Perhaps if I was to if I was to actually maybe take this line right here, we could do something like, could do dereference p, but we could also do p3. Will that actually work? I guess that. Oh, I is, yeah, okay. In fact, what actually happens? So rather than manually moving the pointer, we just do p I, and then we don't care about that one. Okay, all right. That also I would have thought would work, but it didn't. Oh, because we are reading out of bounds. Okay, that works. So if we would set this to size of uint32t, and then whilst I is greater than 0, we decrement I. Should that be -1? Should that be +1? No. We are losing the DE bit. So it's reading from... The heck? It should be reading that AE. No, it's definitely not that. It is 4 bytes we need to read. So that AC is incorrect. But why? Well, maybe it should see, maybe that should actually be -1. Yeah, there we go. So I think if I had a loop, this is what I need it to look like. So but then when I'm looking at init inner data, oh, we're taking 12 bytes at a time, or 4 bytes. Dang, okay. Is this just literally every byte is in reverse? Okay. It may not be that we just reverse each word at a time. I think it might be that the actual data is... Yeah, back to front. Dang, okay. Yeah, I think it is. Okay, so if we were to follow that, it's not necessarily that we want to reverse... Yeah, we need to actually reverse the order of this data. And I feel like that's possible. So we can do that with like a function that will maybe like return a new type where all of the bytes of data are kind of back to front. But I don't think that should work. I think what we want here, so rather than make this a generic like 32-bit, I think this should be just be called like bytes reverse. And what's tricky is I don't want to well, I'd kind of want to do this in place. So I'm trying to think about how we would do that. I guess we need some kind of size boundary. So I'm just going to call this len. I always have the same tracks coming up on my player. Have I got shuffle on? Guess I do now. Yeah, so we have some kind of length. And we need to write bytes back to the data structure. So if we were to do something like that, we need to kind of swap bytes around literally until we get to the middle. Yeah. Okay. Yeah. I guess it's worth doing that. So I think we need some kind of like math library here, because we want to do a floor. So we want to floor this is wrong, isn't it? This header, what did I say? Const size t len. And it's not a pointer either. That should not be a pointer. Yeah. So this one we want to floor. Oh, this just says a double? I guess we need to do the division inside the brackets. Yeah, okay. So this would be len divided by 2. What? What's his problem with len? Oh, narrowing conversion. Yeah, okay. That might be a problem, but we'd never have anything where we need it to be anything, well, anything majorly large. Let's ignore that for the moment. So that's kind of where we would want to stop. And then I guess we need some kind of unsigned character for current. And then let's call this head, and this is gonna be an unsigned character pointer of our, I guess this needs to be source actually. To source. And this is, yeah, so actually this cast is redundant. Don't know why it has a problem with all of this. Oh, I suppose that actually needs to be, yeah, pointer. So we don't want to add stop, but it does need to be source plus len -1. So then we need to say for that something, yeah, we do need to assign to current. So head is at the beginning and tail is at the end, so I guess that actually works. We can keep that dereference value. And then we want to say the at head at head we want to write a value C converted to an unsigned car. So yeah. And then we need to set tail to our current value. What does it not like about cur? Yeah, I guess that can work. And now it's going to recommend I do it the other way. Oh, well, I guess it can be const. Whatever. Maybe that should be fine. Stop can also be made const. I guess that's right. And I guess it's actually yeah, that we okay, it won't do that about long. The other thing that we would need to do is and then subtract tail. I suppose. And it would be interesting to, I guess, in our main function, see if we can reverse these bytes. So this is taking Pokemon data type. But before we do any of this, this is where we have our Pokemon's data loaded. So let's actually create some space for that. And it's 48 bytes. Oh, it's all of these put together. I guess size of Pokemon data type, actually. Yeah. So back where we were. Then let's mem copy or I guess Squirtle. Is it not? Oh, sorry. Squirtle data, and actually the address of that should go to that's destination, so it's actually rev data. Our source is data, and we want to copy size of Pokemon data type. So it would be interesting to see if we were to then call bytes reverse on rev data. What's the issue here? Oh, yeah, I guess so, but then is that not valid syntax? Oh, this is causing problems. Yeah, unsigned character point. What? No, it doesn't like that either. An unsigned character pointer. Oh, maybe it can just be rev data as it is. Perhaps. Because this is saying it actually gets converted to incompatible. Whatever. Point to the first one. Yeah, and let's see what happens there. And we have issues. What do we have issues with? Incompatible integer to pointer conversion. Passing unsigned car to parameter of type cons void. I've seen this before, haven't I? Mem copy. Where am I using mem copy? I probably need to be using an address somewhere where I'm not. Mem copy rev data. Yes, you're right. That needs to be the address of rev data. Okay. So rev data, if we were to look at that in memory view, and let me zoom in so you can see Squirtle's data. Well, actually, if we were to look at the memory view of rev data, let's keep that handy. And then let's look at Squirtle's data. So actually, that looks like it went off without a hitch. Look at that. That's probably like one of the first times I've implemented a function that hasn't gone wrong in C. Yeah, so we should be seeing 0, 0, 16, FF, 0, 6, whole block of zeros, and then when we get to the end, it should be 0A, 74, CF, 8F. Lovely. Okay. All right, so we have managed to reverse those bytes. Nice. So if I go back to normal zoom, what do we have next? Okay, so that has loaded the data in reverse order, and I feel like maybe this is where we need to actually then load according to the data structure. So I'm confident now that we don't need a separate buffer here for bytes reverse. What I think we can actually do is just say that at Squirtle's data, we can do the reverse operation. And then we can do size of Pokemon data type. So that reverses it in place, which is nice. So then init inner data should work, I believe, as we intend, because it's now completely, the bytes are reversed and we're loading them in the order. Let me just check that assumption is right. So it does make mention of the A, B, C, D, whatever structure. Yeah, there. So if you look at each structure is 24 decimal bytes long. Well, we know that. Does it actually say? Although, is this saying that just every... Oh, okay, reverse the bytes to get the encrypted ABCD structure. So 79 through 76 should be my last word. Oh, should I be reversing them in blocks? I mean, is that not what I've just done? I'm not sure. I'm not sure. They may need to be reversed in blocks. So let me actually put that in here as a... reversed in blocks, question mark. But anyway, let's go with what we have. And let's just actually like run this again, but just go straight to the printf breakpoint that we have. Oh. Okay, so in here, I still don't think this decrypted... Yeah, this decrypted value is still definitely not correct. And the encrypted also kind of doesn't look right. So my guess is that this is still not right. So it might be that we needed to actually reverse every word in the structure. That may have made more sense. So I guess we can look at doing that for the moment. So rather than bytes reverse the whole data set, we do it in blocks. So I guess here, this would mean if we know that E is first, we actually want to take this and reverse those bytes. So so if we did bytes reverse if we reverse the bytes before, what's the matter here? Implicit conversion. Oh, with loss of qualifiers. I guess because Pokemon's no longer const. Well, yeah. Oh, man. Okay. Do we want Pokemon to stay const? Do we want Pokemon to stay const? We're writing back to... Oh no, we're making a new data type here, so I guess... Yeah. Okay. I just sound so thrilled, don't I? So this can actually be... No, it's not const. Right, so we then mem copy... We then do that. Why are you complaining? Because I haven't done that. Yeah. Then we want to bytes reverse E instead. And then we want to mem copy DE should be E, size of UN 32T. So in bytes reverse, yeah. I'm also going to put a note in here. Works for odd numbers. Yeah, I guess we would just want to repeat this each and every time. So instead of E, this then becomes A. Yeah, and then I guess we can just do the same for... I'll keep them separate for now and then just change it into one kind of word value at the end. Whoops, that's not W, that's E. E. A. So then this should be M. And then we need one more for G. So basically that. What we should do is initialize this outside of the loop. If this is right. But actually the P data 0 is not. Yeah. Okay. Oh, we have an exception. Bad access. Why is that? So I would have thought P data would be fine. Am I like way out of bounds on the pointer? So Pokemon at this point we have loaded it into Squirtle. Okay, so the Pokemon pointer is not pointing. The pointer's not pointering. So that failed on that iteration. So let's go to here and see what's going on there. So in our Pokemon pointer... Oh, wait a minute. This still isn't reading. What? Squirtle is a pointer. So our Pokemon is P. 0. Or is that just saying where it is in the stack? Yeah, so I guess that doesn't fail to read memory. Dang, okay. So what am I doing wrong? Did it reverse the bytes properly? I mean, that looks crazy. What? 601352. I can't even check to see if that was right, because for some reason that doesn't... That doesn't work. Does that also tell me what it is specifically? Won't even take us to the type source. Maybe I should go back to that breakpoint. Okay, so this reads properly. At this point, anyway. Okay, so it works there. And then it just craps out. Did it load E properly? I can't really tell. I don't actually think it did. Oh, hang on, I might be... Yeah, I'm copying only uint32t. When of course this needs to be unsigned car 12. Wait, no, but I do need to do them words at a time. Oh, man. Okay. Okay, alright, I see my mistake. I see my mistake. So I need to take each of these, like, sections, and reverse them one by one in the order of this. Okay. Okay. So, what is strange though is why... Oh, I suppose we were probably overwriting Pokemon memory or something like that. We probably just completely screwed it. Fine. Okay, I guess in that case we know what we need to do. So if I go back here... yeah, I can try this to see if it makes sense. So these are basically my notes, by the way, that I made. They basically just explain... They're kind of writings from this text file that I've kind of converted into stuff just to remind me. So when we try reversing the bytes, bytes must be reversed one word at a time. So let's say bytes of inner data must be reversed one 32-bit word at a time. E.g., if bytes 0 to 3 are, you know, A, B, C, D, E, F, O1, then bytes 0 to 3 must become 0, 0, E, F, C, D, A, B. Note that we do not reverse the bytes and place them at the end of the data structure. They just are reversed in their 4 byte subgroups, I guess. So that's what we need to do. I will probably leave it there for now because it's getting a little bit late. And yeah, let's try this again next time. So I'm gonna say to do cleanup. And yeah, thank you very much. I will speak to you in the next one. Bye bye.